So as we say, we are going to begin the elective mathematics, and then today the major topic that we'll be tackling is the topic of coordinate geometry one. So let me call it CG1. So that's basically coordinate geometry one. So there are basically three lines that we need to know about. If we are writing WASI, um, can we mute ourselves? Good, thank you very much. Stop you mute. Okay, so there are basically three things that you need to know as how to plot, how to handle lines, straight lines, so straight lines. And you also need to know how to handle circles, and you need to know how to handle parabolas. They are either like this, like that, or like this. So you need to know how to handle this kind of lines as expected from someone that's coming from senior high school level. So we are going to start from the very basic one, which is going to be the straight line. And it's that straight line that the coordinate geometry one is about. The coordinate geometry one is focusing on straight line. Coordinate geometry two is about circles, and then three is about parabola and the other aspects. So it's very important that we take the basics. So yeah, talking about the basics, even for the straight line, we need to start to know how to actually plot a straight line and the variables that come into play. But let me start from here. Let's say the earth that we are on right now is, let's say, circular, for example, or yes, a sphere. It's a sphere. And then let's say Africa is somewhere here, right? It's like a block or something. And then we are somewhere here in Ghana. So inside this Ghana too, there's a particular position that each of us is located. So each of us is located at a point over here. So on the earth, generally, there are imaginary lines that we actually use to locate someone on the on the earth. Basically, we use GPS to locate someone on the surface of the earth. So there are straight lines like these that's coming up longitude and latitude from the north to the south, and then from west to east to there is a particular line, imaginary line that we use to locate every individual person or thing on the surface of the earth. So there are two lines crossing. So wherever any of the two lines meet, that's where they'll locate you. So whenever you are here, there is a particular longitude that defines your position, and there's a particular latitude that's also define your position. So those two lines, longitude and latitude, come together to locate you in the middle there. So wherever you have a person or a thing, there's always a thing that comes, a straight line, imaginary line that helps to locate, and that particular record is what is kept in a GPS. So those lines that help to locate something is basically what we are going to start from at a very basic level. But we started knowing about it already in junior high school, where we are talking about number line. So we all know about number line. Is someone calling me? Okay. Yeah. So the number line, we start. Let me do a straight line like this. So we know about the number line where we had 0 at the middle, and then when we are going from the left, from the to the right, to we have straight lines that we draw going like this, and we also have lines -1, -2, -3. Yeah, so this has been the number line that we're using. It helps us to locate a point. Point zero, we usually do things like this thing going like this, or we're doing something like this to this point when we're working around number lines. Okay, so how does all these things come into play when so this one particular, because we're using one line, I'm going to basically say it is one dimension. So the number of lines we are using to locate something or to manipulate something is going to be the dimension. So it's going to tell you the number of the dimension at the basic level. So one dimension, right? In one dimension, we just have a line. If it is one dimension, you just have a line. We call it a line. That's why this one is called number line. But if it is what we are going to do in coordinate geometry and everything that we are going to do at the junior high school level. So at senior JHS or junior high school, you know about how to use 1D plane, 1D very well. Now, senior high school, you have to know about the 2D the 2D plane, the 2D one. For if it's a 2D, meaning you are using two lines to locate something, to manipulate data. If it is 2D, we are calling it a plane. So if it's a 2D, we call it a plane. There is another one called the 3D. And for the 3D, that's a space. So let's keep that in mind. For 1D is just a line, for 2D is a plane, for 3D is a space. So for 3D, meaning there are going to be three straight lines that is going to define the location of every particular point. But then we are at this level, we are not worried about 3D going. We need to actually master the 2D. So 1D we know it already, and 2D. So now how does the 2D come in? We've also met it so far. It's 2D is basically using two lines such that there is one line going left to right, and then there is one line going up to down. Yes, so this line that goes up and down, we usually call it the Y line or the Y axis. The Y axis, and the one that goes left to right is what we call the X axis. So yeah, this is the basic thing, the basic level of understanding the 2D. So when we have a 2D, it's a 2D, this is a plane. We have a plane, we are using two lines to draw a plane. Okay, so by the specific name for this particular 2D, so we can call it 2D, right? 2D plane, but then there's specific name that we use for them. This one is actually called a Cartesian plane, so we call it the Cartesian plane. So if you see here the 2D plane or the Cartesian plane, they are the same thing. Just the specific name of it. And all these lines, these are the major lines. Wherever they meet, that's point is the zero. The middle point is called the zero, and that's what we call the origin. Where all the lines, all the points start from. We need a starting point. So the starting point is the origin. So basically, so we know about the 2D, have an idea that there's a 3D somewhere. Okay, so in this 2D plane, so I'm going to be using plane mostly. In the plane, there are basically regions that are demarcated. Another thing you have to know about 2D plane is that it also means 2D planes all means that there are two lines that you use. It also means that for you to locate something, for you to locate an individual item, for example, this particular one that is in this plane, for you to locate an item, you need two values, or you need to deliver by two coordinates or two values. So location of each item is defined or completed by giving two separate values, one from the x axis and one from the y axis. So each point or each item that we are going to have, in this case, we are going to be calling them point. So each of them is going to be a point. So point P, or you can call it point A, point B, point C, point D. Remember, for the point, generally we use capital letters for the point. Capital letters for the point. So point E. If we have point small e like this, it's not generally used and not convenient. So we use the capital letters for most cases. If it's a point, it's capital P, capital A, capital D. So use capital letters or uppercase letters to represent them. So that's basic general idea about the planes general. So yeah, so we know that the 2D is going to be representing using point. I know some of you have idea about this already, but some of you just came to know about it, but you don't link it to the whole how do I say it, application behind it. That's why I took my time to actually link it to whatever we did so far, whatever you know from the location on the earth to this one, how everything comes together from the 1D plane to 2D plane. And when you go to upper level, you meet the 3D plane, where you now do things about space. So let's focus on the 2D plane. Okay, so we know about the x axis and the y axis. So you can call them the x coordinates or y coordinates. So this is the y. So basically, this is the axis. Sorry, this is the axis. This is the axis. And then the axis, for example, let me do from the left to right. Right, so you have 0, can go 1, can go 2, can go 3, 4, 5. So the right side of the 0 on the horizontal line are positive, the left side are negative. So this part is going to be -1, -2, -3, -4. They are just like number line, but then now having different direction. So this one, the upper level is a positive on the y axis, +1, +2, +3 going, and here -1, -2, -3 going. So basically, this is how generally a 2D plane or a Cartesian plane is drawn. It's just like you are just drawing a number line, but you now put them together in such a way that there is one going up and there is one going down, going horizontal, one is going vertical to draw the relationship. Okay, so this is the line, the major lines on which you do the numbers, you do the numbering. One, two, three, four. They are called the axis, right? They are called the axis, x-axis. Now, what if if you are going to place a point, you need to we say that if you have a point P, let's say a point is located over here, a point is located over here. That location on that point located, we need to define it by two values. One value from the x and then one value from the y-axis. You need to read one value. Every point that we are going to put in this plane, that point is going to be defined by two values. One from the x-axis and one from the y-axis. Always. And these values that you keep here are going to be the x coordinate and the y coordinate of this point. They are going to be the coordinates of the point. So the line, the straight line that you are seeing is the axis. The points that help to locate a particular thing, that's what we're going to call the coordinates. They come together as a coordinate to make you see that this particular thing is a point or not. Are we good? Any questions so far?
No, please.
Okay, sure. Um, okay. So now we know the x and y coordinates. Now let's try to locate the points now. We should be able to place points on the axis. So here, how do you locate this point? Let's say this point is P. We need to find the coordinates of this point. If I say find the coordinates of this point, it's basically you asking you to find the x value and the y value of this point. So you usually put it in brackets. We do P x comma y. We don't do P equals to bracket x comma y. This equals to doesn't stand. It just goes P, then the bracket follows immediately x comma y. So that's how to locate the point. You put the point against the coordinates. So for this one, you have to locate where the x-axis is. You read the values, you project something, you project it horizontally onto the x-axis, and you see that it is hitting -2. So the x value for this point is -2, comma. We need to put the y value here. So for this point, you need to also project it onto the y-axis. So you project it onto the y-axis, you are reading a value 1, and that will give you 1. So that point is -2 comma 1. Yeah, those are the coordinates of that particular point. So that point is located at that place. If I have a point at this place, let's say point C. So to find the coordinates of this point, is basically you project it horizontally or perpendicularly to hit the x-axis, and the value that you read over there becomes the value for x, and then you project it again from there onto the y-axis. The value that you read from there is going to be the y value. So this is the point and with its coordinates. That's how to basically locate a point. Now let's go the reverse way. Let's do the reverse, where we now have the points and we need to place it on the x-axis. These things are very basic, but then I don't like assuming that people know it, people know how to do. So we are going to take everything from scratch. That's why I'm taking my time. Okay, so let me eliminate this. So now let's say we have a point P -1 comma 3, for example. So if they give you points and they ask you to place it on the x-axis, this is how to go about it. So for the -1, um so a -1 is on x-axis, so you locate it over here. So the -1 is over here. So let me do the cross here first, and then the 3 is on the y-axis. So you go on the y-axis and locate it over there as well. So these two guys are going to meet somewhere. So what you do is that you project horizontal lines such that these 2 points will meet. So trying to find a point where they meet. Where they meet is now become your point P -1 comma 3. Again, let me do another one. Let me say point D is going to be 2 comma 1, for example. So you go on the x-axis, the x value is on the x-axis. So you go on the x-axis, you look at 2, you put let's put a cross over there. The second point is 1. Let's go on the y-axis and put 1 over there. So these two are going to meet somewhere. So you project them so that they meet, such that they meet. So then this become D 2 comma 1. Don't do this. Don't do what I'm coming to say. Let's say you have this point 2 comma 1, and then you'll be able to locate 2 and you'll be able to locate 1. Now, don't be, you have to be smart and then draw the line such that when you project them horizontally and vertically, they'll be able to meet. You have this point and you have this point here. Now, you go and be drawing the line, this one going here, and you have be drawing the line, this one going down. They will never meet. You have to draw them in a direction that they can always meet. This one goes horizontally like that, and this one go up like this. Then they meet over here. Make sure they are straight line, either horizontal or vertical, projecting from the point that you have marked. Let me do another example again to solidify that particular thing that I said. Um, where is this? Um, okay, I think it's clean now. So, or let me just clean everything and draw another line again. Um, Come in a second. This thing is plenty here, and this is black, black, black. Coordinate geometry is also gone. So now let's start. So you go down. So this is should be straight. Good. Then you go up like this. Good. So now let me call, so the origin is 0, the x-axis, and we have the y-axis going up and down. So let me -1, -2, -3, 1, 2, 3, 4, 5, 1, 2, 3, 4, -1, -2, -3, -4. So now, how do we place the point A 3 comma -1? So 3 comma -1, first you go and read this value on the x-axis. So you go to the x-axis, you read 3. So from 0 to 3, so you go and read 3 on the x-axis, you place it here. Now the second point is -1. Go on the y-axis and read -1. -1 is here. Now you need to join those 2 points so that they meet, right? So what will happen is that you cannot go and be doing this one to project like this and this one to project like this. If you project this one going up and this one going like this, they will never meet. So you have to project, be smart and project them in such a way that they will meet over here. They will meet in the plane that they need to meet, or in the region that they need to meet. Are we clear?
Yes, sir.
So it's become A 3 comma -1. So you place the points against the coordinate. Good. These are the basics. These are the basics of everything. Now, there's one thing that one thing that you also need to be used to. Another thing that you need to be used to. That term is what? So let's say, yeah. So these are the regions. I'm going to talk about the region. One thing that you have to know is about the region. So the x and y are separating the plane into 4 places, into 4 regions. This is region 1. This particular side. This particular side to here is region 1. And there's a region between here and then a negative x-axis. So this is region 2. And then here and here is, they are also forming region 3. And this side are also forming region 4. So these regions, right, they are not called regions. There are 4 of them. Because there are 4 of them, we have a name for each of them, and that name is called quadrants. Quadrants. So quadrant, we got 4. Quad is basically 4. Quad is always like 4 things. So quadruple, right? So 4 things. So because there are 4 regions, each of them is called quadrants. So we have the first, so we call this one the first quadrant. We go like this. So we always read from the anti-clockwise direction. From here, positive x-axis, and we go anti-clockwise direction to go like this. So this anti-clockwise direction, we read from there. So first quadrant, second quadrant, third quadrant, and fourth quadrant. First quadrant, second quadrant, third quadrant, and fourth quadrant. That's the direction that we need to follow when you are doing when you are reading the quadrants. So when someone say a particular thing is in the first quadrant, it's in the second quadrant, it's in the third quadrant, you need to draw the picture. We usually start from this region, and in this region is comprised of a region where all the x-axis are. So we have the positive x here, and then positive y here. So positive y and positive x values, when they meet, they are forming the first quadrant. If you come here, if you come to second quadrant, you see the x, we have the negative x values here. That's this line. And then for the y, we have the positive y value. That's the one going up. They come together to form the second region. If you come down the third quadrant, you see that we have the negative x values and negative y values. They come together to form the third quadrant. And the fourth quadrant, we have this one is negative y. So negative y values, and then the x is positive x value. They come together to form the fourth quadrant. Are we okay?
Yes, sir.
Okay. So now I'm going to give you a point, and you tell me the quadrant in which they belong to. You tell me the quadrant in which they belong to. So I have 5, negative 1. I have point A, 0, comma 4, 4. No, let me not trick you yet. Let me not trick you yet. A, 2, comma 7. B, negative 1, comma negative 2. And C, 1, comma 1. So these are the points that I have. These are the points that I have. So our task now is to be able to find the quadrant in which each of them belongs to, right? So let's go with the first point first. Which quadrant do you think that they belong to?
Fourth quadrant.
Which one are you talking about? Which point?
Point P.
Point P, fourth quadrant. Why do you think so?
Yes. Because the x is positive and the y is negative.
Okay, okay, okay. What about the A?
The A is the first quadrant.
A is first quadrant.
A,
Why?
yes, because both the points are positive.
Okay, good, good.
Then the B is third quadrant
Okay, yeah,
because all
that's
the points are negative.
sure.
Then the C is first quadrant because all the points are positive.
Yeah, so that's good. That's okay. Alice, you just join us, right? Can you hear me?
Yes,
Yeah. Solomon, can you hear me?
yes, please.
So I'm talking about Solomon. Solomon, can you hear me? You have muted yourself, so I cannot hear you. Um. So let's continue then. Let me go to. Yeah. So we know about points, and we know how to plot them, and we know the quadrant to which they belong to now. Now let's go to the mathematical aspect of points. Before that, two points come together. So now we are going to talk about a line. So you don't need a, if you have 1 point, you cannot have 1 point. So for this particular 1 point, for example, you can draw multiple lines through that 1 point, multiple straight line basically through that 1 point. Let me clean here so we can have this space for ourselves. So if I just have a point, let's say let me put a point A, a point A over here. I can draw multiple lines to it. Let me clean the name so that we just use there. I can draw a line through this point, a straight line passing through this point like this. I can draw another one passing through it like this. Oh no. this thing is, so they need to pass through that point. I can draw another one passing through that point. I can draw another one passing through that point. Just one point, I can draw multiple lines through it. So if you just have one point, you can draw the multiple line going to any direction at all. But if you are too focusing on a line, that will not deviate you from which one is which one is which. We need at least 2 points. If you have one point, you can draw multiple lines through it. But if you have 2 points, if you have 2 points like this, let's say I have this point and I have this point. Here, a line, you draw a line that joins to this. You realize that you realize that you cannot draw any other straight line that will pass through both at once. There's only one direction, so the 2 points come to give you only one straight line at a time. One straight line at a time. You cannot draw any other line and any other straight line. I'm being specific on the straight line that will pass through the 2 points at once. You can try it, but then they will definitely, it should be a straight line. So 2 points come together to give you a straight line. Is someone calling me? Okay. So 2 points come together to draw you a straight line. But if you are just focusing on one point, you can draw as many points as many straight lines as you want. But if you want to have a definite straight line, you need to have a minimum of 2 points. You need to have at least 2 points. And the 2 points will give you one straight line. That will be that straight line passing through them specifically. We have point A and point B. This is the origin of the entire concept of straight line. This is the origin of the entire concept of straight line. So basically, for straight line, we are going to majorly be focusing on 2 points, point A and point B. We are going to use A and B to define all of them. And each point, as we see so far, they have their own coordinates. So let's say x of A, comma y of A, and then B also have its own coordinates, x of B, comma y of B. So they can ask you, how many points, how many lines can you draw through a single point like this? A point can give you how many straight lines?
Infinite.
Yeah, there will be infinite number of straight lines because you can draw as many as you want through one point. But for you to have a definite straight line, you need 2 points. When you have them at different level, then you draw, there's only one possible straight line that can pass through those points. So the focus of this thing is going to be on the straight line. So if you are talking about straight lines, we are basically looking at something from 2 points going. So it's going to be interaction between 2 points going. So the basic one, I say A and B. So each of them have their own coordinates. S of A, Y of A, S of B, and Y of B. Something like that. Are we good so far? Is there any question that someone has? Alice, do you have a concern?
No, please.
Okay, let me ask. Barusun, do you have any concern?
Oh, it's okay.
Okay, sure.
Mama, can Solomon join me? Yeah, and they said, I want to tell you
Yeah,
something.
yeah, what's that?
We were two, and then one of my friends, the phone is running low, so he decided to off it and join me. Solomon.
Okay, sure. Okay, yeah, I was calling Solomon, but he was not hearing me.
Okay, okay.
Solomon, how are you?
Thank you. Oh, please, I'm fine.
Good, good, good. So let's continue, right? So I'll be asking you guys questions along the way, okay?
Okay.
Yeah. Okay, so now we know that 2 points are going to define this. So now the first thing that we need to know the difference between straight line. So you have to know the difference between a line and a line segment. Line segment. So segment, yeah, they are different pronunciation, but that doesn't matter. Segment or segment. So let's see. So the difference between a line and a line segment. A line segment. We say they are good for you to have a straight line. We need 2 points. So let me do this and this, and then let's say point A, point B. So I'm going to draw a line. Remember, I'm going to draw a straight line between these. This is a line. The one I'm passing from somewhere infinite pass through the 2 points and go. That becomes a straight line. Now, what is a line segment then? A line segment is just a portion that joins the 2 points. So it means that when you are drawing a line segment, you don't go beyond the point. You join the point A to point B like this. That's all. The first one is a line, straight line altogether. But if you are talking about a line segment, we have point A and point B, and when you are drawing the line between them, don't go beyond them. If you go beyond them, you are no more having a line segment. You are just having, so we are focusing on this line segment. This is a line segment. From A to B is a line segment. It's a line, but it's a special type of line, which is a line segment. But if you say line, straight line, it definitely has to continue going. Are we clear?
Yes, please.
Good.
Yes, sir.
Good. So that's the basic difference between a line and a line segment. Okay. So now that we know the line and line segment, one concern will be if I have a line segment. So sometimes I can be using it interchangeably. If I have a line defined by points A and points B, how do we know the distance between this and we need to know how far is A from B and how B is A from A. We need to know that value, that distance. So distance between 2 points. That's where we are driving at now. So let's say we have point A, we have coordinates s of A, comma y of A, and then point B, y of A, comma, no, it's x of B, sorry, comma y of B. We need to know the distance between these 2 points. To find the distance between these 2 points, there's a general formula, right? So now look at the symbol. Look at the symbol I'm going to do. If I do A, B, O, okay, before we go to the distance, sorry, before you even go to the distance, I need to show you something. I need to show you something concerning line and line segment. Concerning line and line segment. If I just come and I give you to draw something for me like this, AB, or I say, knowing that A is 2, 4, B is 1, 2, I want you to draw AB for me. And I put it in bracket like this. And I also draw AB like this. And I say AB like this, and I say AB like this and like this. So how do we draw these things? So basically, I'm going to assume that the values are not given, but then let's say we have 2 points A and B. So I have point A and then point B. Let's draw the first one. Let's draw the first one. So now this one means that if you have the bracket, the normal bracket around the point, around A is a normal bracket, around B is a normal bracket. Whenever you are having a normal bracket around the point, it means that draw the line to bypass that particular point, to go beyond it. That is what it means. Go beyond that particular point. If you have the square bracket, it means stop there. Don't go beyond that point. Are we good? Let me
Yes,
draw the
please.
first one. So we are
Yes,
drawing
sir.
AB. AB means that you see that A says go beyond, B also go beyond. So now this is what we normally get. But then we say A is like go beyond because of the normal bracket. So if you need to draw something like this is the line AB opening up. It's everywhere is open up. So you need to know about that. The second one, let me draw the second one. So let me put this one like this. Like let me label it so that you know that this one is AB. Now let's draw the next one is AB and both sides are having square brackets. This means that if I ask you to draw something like this, so square bracket A and B, but then on the A is closed and the B is closed. So you are not going beyond. So you just stop. So this is AB with the segment closed on it. That's one thing that you need to know. The next thing is I did this A, B. It means that you have A and you have B, but the A is closed, so you cannot go beyond the A. But for the B is open because of the normal bracket, so we go like this. Does it make sense?
Yes,
Yes,
please.
sir.
Good. And the last one is A, B, and this one is closed. So it means that, who will guide me on this one? Let me put the point A and point B. Who is going to, yeah, Alice.
Sir, please the point A.
You said,
Please the point A. The point A.
yes, as that what?
Will go beyond, and the point B will stop at the fifth point square.
So you are talking about this one.
Yes, please.
Um, Solomon and Yakat, is it correct? But their network, are they there? Borusun and Solomon, can you hear me? Kennedy, is she correct?
Yes, sir.
Okay, so you also agree. Nice one.
Yes, sir.
Yes, it's correct. It's correct. So those are the various versions of line and line segment. So this is a line segment, and this is what?
A line.
Yeah, it's basically a line. Good. Now, so we know how to draw the line even from the symbols. So we keep that in mind. What is evolving? So let's have these ones on the side. Um, okay. So now we know how to draw the points and lines. So now, if you have a line segment, if you have a line segment, how do you know the distance between the 2 points? That become the next concern that we wanted to tackle. So let's say we have x of a comma y of a, and the point b is x of b comma y of b. How do we know the distance between these 2 points? So the distance between these 2 points is in hand. That's where I wanted to draw this particular symbol for you. Look at this one. When they do AB and they do straight line like this around it. When they give you AB and they give you straight line around it, it's different from the top ones here. This one are brackets, square brackets and normal brackets. But then if they put straight line around it, they are looking for the distance between the distance between the 2 points. If you just see these straight lines, so something like, they can put a question like, oh, they give you A 2, 3, B 4, 5. They say find so they say A, they do like this, AB, and then B, AB, straight line. The first one is what? What do you
A
think the
line
first?
segment.
Yeah, the first one is a line segment. The second one is what?
I can see the second one.
The second one, this one. Can you see it?
No, please.
This is the second one.
Yes, please.
Then it's what?
Yes, please. The distance.
Yes. They are finding the distance. So you need to be used to those particular symbols around them. You see them, this particular one, you see them mostly in the book. They won't ask you to, sometimes they'll be like, oh, find the distance, but then sometimes they just put a thing around it, find AB, and this symbol is around it. They ask you to find the distance between the 2 points. Now, to find the distance between the 2 points, this is how to go about it. We are going to go slow first, then we put them together. Each of the points have their x values and the y values. They have the x values and the y values. So what we do is that, so we are going to find the change in x. So if you see this delta, something like this, like a delta, we call it the delta. It's like a triangle, like this, and then we put the x. It just means change in x. Change in x. We are changing the x values. So meaning we are doing difference. So what we'll do is that I'll do x of a minus x of b. That's it for two. Then we also find change in y, which is equal to y of a minus y of b. It doesn't matter. You can also do like changing s. You can do x of b minus y of s of b minus y of minus s of a. You can do that, or even this one you can still go with. It doesn't matter which one comes first for this particular case. For finding distance between 2 points, which one comes first doesn't matter. Whether the y of the a comes first or the y of the b comes first, it doesn't really matter, because at the end we are going to square it. So but then what you have to know is that you have to make sure that you find the difference first. You have to find the difference first between a and b. And when you are done finding the distance, what you do is that you now square it. So the distance, the result that you get, you square it for the x, and then the distance you get for the y, you also square that one. The result, the difference that you get, the value that you get from here, you square each of them. So after squaring them, now you add them. After you square them, after squaring them, then you add them together. So you're now going to put them together. It's going to be this one square plus this one square. This one is going to be added. When you are done adding them, the final distance, let me say distance. So let's say if you add them, you have a result. Let's the result be called r. That result, the actual distance is equal to square root of the result. I'll go over again. So we go step by step. When you have 2 points, you first find the change in the x values, you find the change in the y value. When you are done, you square the x value that you got, you square it. The y value that you also get from doing the difference, you square them. After squaring them, you put them together. When you put them together, you find the square root of the result that you get. That becomes the distance. Let's do an example. I think I gave a point here. So let's say point A is 1 comma 3 and point B is 2 comma 2, for example, and we are asked to find the square root first. And I'm going to find the change in x. Change in x is going to be, I'm going to take the x of a and then take the x of b. So I can do 2 minus 1 or 1 minus 2, it doesn't matter. 2 minus 1, that will give me 2 minus 1 will give me 1, right? So now after that, I find change in s squared. When you have the result, you square it. So we had 1, so 1 squared, which is equal to 1 again. So we are safe. So I've got for the change in s squared. I'm going to change in y. Change in y is the y 3 and 2, right? I'll do 3 minus 2 equals to 1. So what I do mostly is that I make sure when I'm doing the difference, it doesn't matter. I just put the one that is bigger before the smaller one, because the order doesn't matter. So I have change in y equals to, it's change in y squared is equal to 1 squared, which is also equal to 1. Now after you do that, you put them together to have my result. The result that you get from this thing, you now do 1 plus 1, because you got 1 from here, you get 1 from here, that becomes 2. So now what's the final distance? The final distance AB is equal to square root of 2, because that's the result, square root of 2. Then you put in the calculator or you keep it like this. So that brings us to the general formula, which we usually use for finding distance between 2 points, is equal to square root of, so we can have SA minus s of b all squared plus y of a minus y of b all squared. This is the square root of all that. So all the steps that I've broken down, this is what it finally means. This is the final equation to find the distance between 2 points. So first, you need to make sure that you do the one in the bracket, SA minus SB first. When you are done, the result that you get, you square it. Then you do for this one, ya minus yb. The result that you get, you square it. Before you add them, do the squaring before you add them. After you add them, you put them under this bracket. Then that gives you the final equation. Are we okay?
Yes, sir.
Alice, are you there?
Yes, please. Sir,
Okay.
is this formula different from the one you just did.
No, it's the same thing, but this is the all of them put together. This is the general formula. But the one I did first
Okay.
is a step by step. I tried to find the one, the change first, and I squared it. In S,
Okay.
I also did the change in Y, and I squared it. After squaring it, then you put them together. After putting them together, then you find the square root of it. Then it's all
Okay.
that is summarized in this particular general equation. I didn't want to give you the equation straight, right? But all of them will give you the same answer. Are we okay?
Yes, please.
Okay. So now let me give you guys questions too. So Kennedy, you have this 3 comma negative 1 and the point B comma 2 comma 5. Find the distance between these. And Alice, you have point C 4 comma 3 and then point D 1 comma 1. Um Solomon, are you guys there? I want to give you guys a question to find the distance.
Yes, please. We are there.
Okay, so I'm going to give one to each of you. Are we fine?
Please, is that
I'm going to give you one.
okay? Okay.
So for Solomon, this is for Solomon. So E negative 5 comma 1 F 2 comma
Oh, yeah.
1.
That's minus two. Minus.
So this is for Solomon.
Minus two. Minus seven. Minus seven squared.
This is Solomon.
49.
And then I'll give the other one to G
Yeah.
1 comma negative 7 H. The point H is negative 2 comma negative 1. This is for Yaka. Yaka, are you there?
Yeah.
Yeah. So I have your point here. So let's. This is for Alice.
One minus one zero zero squared zero. This is minus two. Yes. One minus two 49 plus 3.
So you have Kennedy.
Minus seven.
So whoever is ready, let's see.
Minus two. Oh, minus two. That's yes. Please, someone had seven.
Solomon has 7.
Yes, please.
Okay, Solomon said he has 7. What about you?
Sir, please, I got 13.
13.
Two,
Okay.
three. Oh.
Kennedy and like I'm waiting.
Sir, I got 1.4 of A. I got 6.08.
Give me the square root of what you get.
37.
Square root of 37. Okay.
Yes.
You can leave it as square roots. That's what they mark mostly. They mostly mark it as the square root of this thing. Or if it's square root, leave it like that. And so he's left with one person. We are waiting. Solomon is your friend there. They've muted themselves. So. Or that question is tough.
Yeah.
Yes.
Yeah, I have square root of 45, but I want to still give the answer, but I'm not having calculator.
Okay, square root of 45. That would be 9.
45, yes.
That would be 3 root 5.
Okay, 3 root 5.
Yes. Okay, so let's confirm. Let's confirm quickly. It's almost time. We have 5 minutes. 5 minutes to close the class. So let me start from Kennedy. So let's see Kennedy's own. Kennedy, the difference between this and this, that will be 3 and 2. That will give you 1. 1 squared is 1 plus 5 minus 1, that will be 6. C squared is, so that is C squared. So 1 plus 36. Yes, that will give you 37. So square root of 37. So Kennedy, you are correct. Let me go to Alice. Alice is 4 minus 1. 4 minus 1, that will give you 3. 3 squared plus 3 minus 1, that will give us 2. 3 minus 1, that will give us 2. That will be 2 squared. That will become 9 plus 4, which is 13. Kennedy, Alice, you forgot to find the square root
Square
after. Alice, can you hear me?
Calculate.
Yeah,
well,
so
actually, let me
you
get
leave
a
it like that.
calculator.
You say square root of 13. Okay, okay,
Yes, please.
okay. So it's square root of 13. Let's confirm Solomon's own. So it's negative 5, 2 and this. That will give me 7. Oh, that will give me 7 squared, right? So 7 squared. 1 plus 1, that will be 1 minus 1, that will be 0. Yeah, 7 squared. Square root of 7 is 7. So Solomon is correct. Let's go to the last one. Um, that will be 3 squared plus this is negative 1. That will be 6 squared. That will give us 9 plus 36, which is 45. So the square root of 45. Yeah, that's correct. That's very correct. Yeah. Okay. So this is good. This is good. Well done, everyone. So there have been a lot that have been covered today. So you can work around some points and see if you get the same answers every time and solve questions.